I will first show you a ballast which does not have a power factor controller. This is a 40-watt ballast sent to my lab for testing from my Puerto Rican client who kept having failures in the street light. If you look on the radio frequency part, which is around 200 kilohertz, the distortion is very low. The power factor is excellent. Now, if you look on the mains input grid here in France, 50 Hertz, this is the current, hence the problem. You can see the distortion is huge. Using the current probe, I can, with this instrument, make an estimation. It's beyond 80%. So the first thing is so much distortion, plus very hard to tell what is the power factor mathematically. It does not meet a regulation. Plus, it creates a lot of stress and premature aging on the ballast itself. Now, I will show you a ballast which has a power factor controller. This ballast, which is an 80-watt ballast, was sent by my client in the USA, and he was very happy in the street light with it. If you check the radio frequency, again an excellent power factor, very low distortion. This one is running at 220 kilohertz. And the key thing is here. If you look at the current and the voltage, so you can see here, now you can finally estimate when you are power measuring and estimating the power factor. It's very small. And if you look here, the current, what's the distortion? It's 7%, having in mind there is some distortion also on the voltage. So in fact, this ballast has much less distortion. This is very important to have a very high power factor, near 1, very low distortion, so you make a lot of energy savings, plus you comply with the regulations, because you don't want to use reactive power being charged or not charged from the grid, plus that reactive power, you don't want that to make electronic stress with premature aging on your ballast.